Hello Math 95. We're going on to section 8.3 in this video. So section 8.3 is still about factoring. It's about factoring trinomials, and we've already learned trinomial factoring, but this is when there's an extra complication to it, and that is when there is a number in front of the x squared. When there's a number in front of the x squared, there's going to be more to it, a little bit more to it than earlier. Let me just remind us what trinomial factoring looks like. Let's say we have x squared plus 5x plus 6. We're trying to figure out how we need to break this apart into two different binomials that would multiply to get this if you were to distribute. So these two things multiply to get x squared, so that's going to be x and x. These two things have to multiply to get 6 while also adding to get 5. So that's going to be 2 and 3. So that's how you factor that. And it's pretty simple like that when there's nothing in front of the x squared, but when there is a number in front of the x squared, we have to take a couple more steps. There's a lot of different ways that this can be done, a lot of ways that it's taught. If you have a way that you already know well and you're good at it, feel free to do that. The method that I've kind of settled on in teaching, it seems like students grab a hold of this pretty easily. It's called the AC method, or also known as the slip, slide, slip method. So what you do is you take this, if you think of this term as the A term, the B term, and the C term, it's called the AC method because you take the A, the coefficient, and you take it down there and multiply it with the C coefficient. So you make a new trinomial that's just going to be x squared plus 14x plus 3 times 8 is 24. All right, so then we're going to do it just like we did the trinomial factoring. So what two things multiply to get x squared? X and x. And then we're still trying to do what two numbers multiply to get 24 and add to get 14. So if you have to, make you a list of, here's a 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you say, can any of these add 14? Well, 2 and 12 can. And so since it's a positive, multiplying to get a positive, they're both positive or both negative, and since it's adding to get a positive, then it's going to be both positive. So x plus 2 and x plus 12. But it's not as simple as all that, because when we multiply that 3 down there with that 8, we made a different trinomial than what we started with. We kind of cheated. And so now we have to undo that. We have to uncheat. And so the way we're going to uncheat is, since we multiplied the 3 earlier, now we're going to divide the 3, and that's going to undo what we just did. So we take these two numbers that the 24 became, and we divide both of them by the 3 that we multiplied earlier. That number right there is what goes under here. We divide both of these numbers by 3. And then, if you can reduce the fraction, reduce the fraction. Like this one here can reduce. What does it reduce to? 12 over 3. Reduces to 4. So that just becomes x plus 4. And once you reduce, if you can't reduce anymore, or if you can't reduce at the beginning, if you still have a number on the bottom of this fraction, you're going to put it back in front of that x. You're going to put it back in front of the x that is in that parentheses. So that is going to become 3x plus 2. So this is it. That's it. That's how you factor it. Now let me say why I like to also call it the slip, slide, slip method. Because it reminds us of the 3 steps that we have to do that are different than trinomial factoring. We first slip slip this first number down there with that last number. Then after we factor it, like the trinomial method, then we have to slide that 3 back up under those two numbers. And then finally, after you reduce, if there's still a number on the bottom, you got to slip that number back in front of that x. Slip it down there, slide it under, and then slip it back in front. Slip, slide, slip. So that's certainly one good way to teach this. Let's do another. 2x squared minus 3x minus 9. All right, so first we do AC or slip the 2 down there with a 9. So we say x squared minus 3x what? Minus 18. Then we do our good old trinomial factoring that we've gotten good at. We say what multiplies to get negative 18 and adds to get negative 3. Well, I'm thinking a 6 and a 3 can do that, because they got to be opposite signs to multiply to get the negative 18. So how can they be opposite signs, and one positive, one negative, and add to get negative 3? Well, if the bigger term is negative, if the bigger number is negative, a negative 6 and a positive 3, that'll do it. That multiplies to get negative 18, and it adds to get negative 3. Now I have to slide that 2 that I slipped down there earlier. I have to slide it now under these 2 numbers and then reduce. Well, this one will reduce. X minus 6 over 2 reduces 3. This one won't reduce, so I now slip this 2 back in front of its x term. So the 2 goes in front of that x, so now it's 2x plus 3. Let me just show you one time that you can check yourself to see if you've done this right. You can distribute or FOIL this. So x times 2x is 2x squared. X times 3 is plus 3x. Negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. Combine these like terms in the middle, we get 2x squared minus 3x minus 9, which matches up with what we started with. So that's how we can know that we did factor it correctly. And that should work out every time. If we follow the steps correctly, that will happen every time. You don't have to check yourself, but I'm just showing you that it is possible to check yourself. All right, let's take that up a notch. All right, we're taking this AC method and we're going to kick it up a level. So remember, hopefully you remember that I said this before, that of all these kinds of factoring, we've learned GCF, we've learned trinomial, we've learned difference of squares, and now we're learning AC, or slip, slide, slip. There's one of those kinds that you should always look to do first before you do any other kind, and that is GF. I said this before, I think, but let's reiterate it. Always look for a GCF first. Always look for a GCF first. If you can factor out a GCF, do that first. You do any other kind of factoring. So let's take this problem for example. We're looking at this, we're thinking, what should I do? It's a trinomial. Can I do trinomial factoring? But the first thing you should look for on every problem is there a GCF I can take out of this before I do anything else? All right, so for this problem, there is a GCF. What is the GCF I can take out of these 3 terms? Well, for a 15, 39, and 18, that would be a 3. And for an x to the 4th, an x to the 3rd, and an x squared, that would be an x squared. You can so if you have variables of differing exponents, you can always take the lowest exponent variable out of all 3, or out of all the terms. So if you're between an x to the 4th, an x to the 3rd, and an x to the 2nd, I can take an x to the 2nd out of all 3. All right, now I'm going to put what is left when I divide this 3x squared out of all 3 terms. I'm putting what's left in this parentheses. So if I divide a 3x squared out of this 15x to the 4th, I have a 5x squared left. Think about if I multiplied 3x squared with 5, I'd end up back with the 15x to the 4th. Minus, okay, divide the 3x squared out of the 39x cubed, you're left with 13x. Divide the 3x squared out of the 18x squared, you're left with just 6. Okay, so we have factored out a GCF. That was a good first step. But we should always look to factor completely. Factor completely. In other words, after I've done one kind of factoring, look at it again and start over and say, well, can I factor this some more? Like in this problem, can I factor this part more? And the answer is yes. I can treat this like a brand new problem and say, can I now do another kind of factoring on here? I can do the AC method. I can do that slip, slide, slip method where I'm going to take that 5, multiply it down there with that 6. The 3x squared that I took out is just going to come along for the ride. Okay, I'm going to keep it in mind. I'm going to write it with the final solution. But I'm just going to focus on this part for now. So multiply that, I get x squared minus 13x plus 30. Then I factor this x and x. What multiplies to get 30 and adds to get negative 13? That would be a negative 10 and a negative 3. Then, so I slipped the 5 down there with the 6. Now I'm going to slide the 5 back up under these two numbers. And I'm going to reduce if I can. This one will reduce. It reduces to x minus 2. This one won't reduce. So I take the 5 and I slip it back in front of that x, so that becomes 5x minus 3. And remember that 3x squared, it's going to just come down as just part of this final solution. It just comes along for the ride. So this is the final way to factor completely the original problem. If we distributed that 3x squared into here and then FOILed that result with this, we would end up back where we started. All right, let's do another. Let's see here. All right, why don't you pause this and go ahead and try this one. And then we'll do it together. All right, this is just a plain old AC method problem. Take the 6 down there with the 8, x squared minus 19x plus 48. And then I do the factors of 48, 1 and 48, 2 and 24, 3 and what? Let me give you a little trick here. If you want to know if something is divisible by 3, you can take the digits of the number, like here it's just a 4 and an 8, and add those digits. And if that comes out to be a multiple of 3, then 3 will go into it. It's kind of a neat trick. 8 plus 4 is 12. 3 is a factor of 12, or 12 is a multiple of 3. So I know that 3 will go into 48. So now I just got to think 3 times what gives me 48. That'd be 16. And 3 and 16 looks like it's already going to be a winner here, because 3 and 16 could give me 19. So I'm going to factor this as x and x. And since it's positive, got to both be the same sign. Since that's a negative, they're going to both be negative. Negative 3, negative 16. Then remember to now slide that 6 back up under there and reduce, like this one reduces to 1/2, x minus 1/2. This one reduces x minus 16 over 6. They both divide by 2. That's 8/3. So now they've reduced, but after reducing, they still have numbers on the bottom. So now I got to slip both of these numbers in front of their x's. So that's going to be 2x minus 1 and 3x minus 8. And that's the answer. Okay. Let me do another where we have to factor completely. Let's try this one. 20x to the 4th minus 40x cubed minus 25x squared. Go ahead and try this one on your own, and then we'll do it together. All right, so what can I factor out? Is there a GCF that I can factor out of here? And there is. It would be a 5 and x to the 4th, x cubed, x squared. I can take the x squared out of all of them. So divide all these by 5x squared. It leaves me with 4x squared minus 8x minus 5. Then I take this part and I try to factor it some more. Let me see if it can. Let me take the 4 down there and multiply it with the negative 5. For now, just leave the 5x squared alone, and remember that you got to put it at the end with the final solution. So this is going to be x squared minus 8x minus 20. And what can multiply to get negative 20 and add to get negative 8? That would be, I think it's going to be a negative 10 and a positive 2. And then we get to put the 4 back up under there. All right, I'm going to come over here now. So that's going to reduce. It's going to reduce to x minus x minus 5 halves and x plus 1 half. And so then take the two things that are still on the bottom and move them in front of the x's, and that gives me 2x minus 5 and 2x plus 1. What am I forgetting? Don't forget to bring that 5x squared that you factored out originally, and that is still in front of everything. And so that is my final answer. I think that's probably should give you a good foundation for trying to do section 8.3. We are pretty much done learning how to. The only thing left now is to learn how to solve equations by factoring, which is not going to be much more than what you've already learned. So good luck on your 8.3 homework. I'll see you again when we get to, we're actually skipping 8.4 when we get to 8.5.